Good evening, students. So, last class we have completed the synopsis. So, today we'll start with the MCQs for DNF block elements. So, the first question, scandium, which is having the atomic number 21, is a transition element, but zinc, okay, zinc, which is having the atomic number as 30, is not, because both scandium plus 3 and zinc plus 2 ions are colorless and form white compounds. In case of scandium, 3D orbitals are partially filled, but in zinc these are filled. Okay, then C option, last electron is assumed to be added to 4s level in case of zinc. And D, both scandium and zinc do not exhibit variable oxidation state. So this was a question asked in NEET 2013. Okay, so you can try to solve this answer. So scandium, which is having the atomic number 21, okay, it is a transition element, but zinc, which is atomic number 30, is not. So zinc, what they are saying, that zinc, it is a transition element, but zinc, scandium, which is a transition element, okay, but zinc is not a transition element. What is the reason, they are asking? So what will be the answer? So zinc, you know that? Yes, I got one answer. Priyanka has answered it as B. What about others? Okay, so you know that zinc, okay, so zinc, it does not show what you can say, many oxidation state, or it does not show variable oxidation state. Okay, so zinc, it does not show variable oxidation state, it shows only +2 oxidation state. So zinc, it will show what? It will show only +2 oxidation state. Then when you're talking about scandium, so the first, so Komal, so okay, so here scandium is showing +3. So scandium, it shows +3 oxidation state, and zinc, it shows +2 oxidation state. Okay, so scandium +3, it will become 3D0. Okay, and zinc, when it shows +2 oxidation state, it becomes 3D10. Okay, then you can say that there are unpaired electrons. Okay, so when they are unpaired electrons, so there are unpaired electrons, right? Unpaired electrons are present, so because of it, it will show colorless. Okay, there are no unpaired electrons, so because there are no unpaired electrons, then they will be colorless. So if you have a unpaired electrons, okay, so here it is 0 and here it is 10, so all the electrons are paired here and there are no electrons in d orbitals. If you have unpaired electrons, then only they will be colored. So as there are no unpaired electrons, so it is colorless. So first point is okay. Then we'll go for the B point. B point, what it is saying, in case of scandium, 3D orbitals are partially filled. Is 3D orbitals partially filled? Only there are, okay, if you see scandium, then scandium will be 4s2 and 3d1. Okay, scandium will be 4s2 and 3d1. So the scandium, it is not partially filled. Partially filled means what? At least half should be filled. Okay, means what? Partially means like this, half filled. Okay, partially means half filled. Is it half filled? It is only one electron. So scandium is not partially filled. So this is, you cannot take this option. Then, but zinc electrons are filled completely. Yes, zinc electrons are filled completely. Okay, they are completely filled because it is 3D10. But in case of scandium, it is not partially filled. So this option is overruled. Then C, last electron is assumed to be added to 4s level in case of zinc. So in case of zinc, it is added to yes 4s level. Okay, so this is also correct. Okay, so this can also be the so this can also be overruled. Then next point, both scandium and zinc do not exhibit variable oxidation state. Okay, so zinc it will show scandium it will show +3 oxidation state, and zinc it will show +2 oxidation state. Okay, so this is also correct. So which is wrong? It is B. Okay, so in case of scandium, 3d orbitals are partially filled. No, it is not partially filled because there is only one electron. Partially means what? It should have half filled. Electrons are half filled, but it is not half filled. So it is not half filled. Okay, so it is so option B is the right answer. Okay, so others have also answered. So Komal, Priyanka answers are right. Okay, so Komal and Priyanka has also answered it right. So it is option B. Okay, so we'll go for the next question. Which of the following ions have electronic configuration as argon 3d6? A, nickel 3 plus, B, Mn 3 plus, C, Fe 3 plus, and D, cobalt 3. Okay. D. Okay, Komal has answered at D, Anvita D, Komal as B. Okay. So the answer, so we'll just see. Okay. So argon 3d6. Okay, argon 3d6. So when you write the electronic configuration, for first I'll write for nickel. So nickel, what is the atomic number? It is 28. So at 28, then how will write it? Argon 3d8 4s2. Okay, then nickel is present in +3 state. So +3 state means argon. First, the electrons will go from s orbital. So 2 electrons will go from here, 1 electron will go from here. So it becomes 3d. It becomes 3d7. Okay. Then we'll go for Mn. Then Mn 3 plus. Okay, Mn plus 3 again here. Mn is what? Mn is 25. Mn is 25. So it will be argon. So argon, okay. Then Mn will be 3d5 and 4s2. So again here Mn, if it is +3 state, then argon, okay. Then 3 electrons, 2 electrons will go from here, 1 electrons will go from here. So it will become 3d4. So this is also wrong. Okay, so not this, not this. So the next is what? Fe. Fe is what? 26. Argon. Okay, then this will be argon 3d6 and 4s2. If it is Fe plus 3, okay, then 2 electrons from here, this 1 electron, so it becomes argon 3d5. So this is also wrong. Then we'll check the next one, that is cobalt. Cobalt is what? Cobalt is given as 27. So cobalt is 27. So again, argon 3d7 and 4s2. So cobalt, when it is cobalt, when it is +3, it becomes argon. So 2 electrons will go from here and 1 electron will go from here. It becomes 3d6. So it will be D option. Yes. So yes. So D is the correct answer. So many have answered it as D. Yes, good. Okay, so D is the right answer. So we'll go for the next question. I hope you have got it. Okay. So you have to write the electronic configuration and you have to see which is the right one. Okay, so we'll go for the next one. So next question, among the following series of transition metal ions, the one where all the metal ions have 3d2 electronic configuration is. So what you have to do, you have to see that all these ions, okay, the set of ions, they should show 3D2 configuration. So I'll check the first one. So titanium plus 3. Suppose I'll check for 1. If first one, if it is showing 3D2 configuration, then we can check for the others also. First one, if it is not showing 3D2 configuration, then that series is wrong, right? Any one also, if it is not showing, then that set of series will be wrong. Then, so titanium plus 3. So titanium is what? Titanium is 22, right? Titanium is 22. So argon, 3D2 and 4s2. So if it is titanium plus 3, then how it will be? Titanium plus 3 will be 3D1. Okay, it will be 3D1. So this will be 3D1, right? It will be 3D1. So this is wrong, right? So it will be wrong. So if it one also, if it is wrong, then this will be wrong. So this is wrong. So the overall set also will be wrong. Then we'll go for the B. We'll check for titanium plus. Okay, titanium plus. Okay, then this will be argon. Then 3D2 and 4s2 plus 1 means what? It will go from here. So it will become 3D2 and 4s1. So this is showing 3D2 configuration. Okay. So now we'll check for the next one, that is V4 plus. That is vanadium 4 plus. Vanadium is what? Vanadium is 23. So this will show electronic configuration as argon. Okay, argon. Then argon 3D. So argon 3D3 4s2. Okay, argon 3D3 4s2. Vanadium, when it is in plus 4, so first 2 electrons will go from here, then the next electron will go from this. So this will be what? It will be 4s0 and 3D1. So 2 from here, 1 from here. So this becomes 3D1. So this is also wrong. Okay, 3D1 means this also will be wrong. Understood? So we'll go for the next series now. So next we'll check for, so this is wrong, this is wrong. So titanium plus 4. So titanium plus 4. Again, this is what? Argon 3D2 and 4s2. Then titanium plus 4. This will be what? It will be 0. Right? It will be 3D0. So this is also wrong. Titanium plus 4 also, this will be wrong. So full set will be wrong. Then we'll go for the last one, that is titanium plus 2. Titanium plus 2. So this will be argon 3D2 4s2. So what will be the electronic configuration in plus 2 state? It will be 3D2. So this is correct. Now we'll check for vanadium plus 3. Vanadium plus 3. It will be argon. Okay, then 3D3 4s2. When it is vanadium plus 3, then first 2 electrons will go from s orbital, then 1 electron will go from here. So again, it will be 3D2. Then we'll check for chromium plus 4. So chromium plus 4, the oxidation state of chromium is argon. Okay, then 3D5. Okay, 3D5 and 4s1. Then the electronic configuration for chromium plus 4. Chromium plus 4. So chromium plus 4, what it will be? It will become 3D. So first electron will go from here and the next 3 electrons will go from here. So it will become 3D2. So 5, 6, 6. So 4 electrons go, it will become 3D2. Okay. So this is also right. Then we'll check for Mn plus 5. Then Mn plus 5 for Mn. For Mn, the oxidation, this will be electronic configuration is argon 3D5 and 4s 2. Okay, 3D5 and 4s1. Then when Mn is plus 5 state, then this will become what? 2 electrons will go from here first and then the remaining 3 electrons will go from here. So it will be 3D2. So option D is the right one. So all the electrons, okay, all the electrons. Yes, all the, what you can say, all the metal ions in this D series, okay, they are showing 3D2 configuration. I hope, is it clear? Okay, so we'll go for the next question. So these were some of the questions based on electronic configuration of D block elements. Okay. So now we'll go for general properties. So we'll solve some MCQs based on general properties. So general properties of transition elements. So this question was asked in NEET 2021. Okay. So zirconium, it is having the atomic number 40. Zirconium is having the atomic number 40 and hafnium is having the atomic number 72. So they have atomic and ionic radii, similar atomic and ionic radii because of why they have similar atomic and ionic radii. A, having similar chemical properties. B, having belonging to same group. D, C, diagonal relationship, and D, lanthanide contraction. Yes, why they have the similar ionic radii? Okay, Jyoti D. Anvita has replied it as D. Yes, it is D. It is because of lanthanide contraction. Okay, it is because of lanthanide contraction. You know what is lanthanide contraction? So from lanthanum to lutetium, okay, the ionic radii, it goes on decreases. So why this ionic radii goes on decreases? Because of 4F, poor shielding of 4F electrons, right? Because of the poor shielding of 4F electrons, the ionic radii goes on decreasing. So in 6s, okay, in 6s, the electrons will attract towards the as the electrons. So the electrons in the 6s orbital, they will be attracted towards the nucleus, and thus what will happen? This will be ionic size will be decrease. Okay, the ionic size will be decrease. So thus the ionic size goes on decreases. So what is the reason? So you know that zirconium is present in 4D series, hafnium is present in 5D series because of this lanthanide contraction. Okay, because of this lanthanide contraction, what will happen? They will have equal size. They will have similar atomic and ionic size. Okay, so the ionic and atomic ionic and this radii goes on decreases because of poor shielding of 4F electron. So because of that, the electrons which are present in 6s orbital, they will be attracted towards the nucleus, and thus the size will go on decreasing. So option D is the right answer. I hope it is clear. Okay, so we'll go for the next question. So identify the incorrect statement. Okay, you have to identify the incorrect statement among the following. A, chromium plus 2, that is D 4. Okay, D4 is a stronger reducing agent than Fe plus 2, that is D6 in water. B, the transition metals and their compounds are known for their catalytic activity due to their ability to adopt multiple oxidation states and to form complexes. C, interstitial compounds are those that are formed when small atoms like hydrogen, carbon, or nitrogen are trapped inside a crystal lattice of metals. And D, the oxidation states of chromium in CrO2, O4 2 minus, and dichromate, that is chromate and dichromates are not the same. So they are so which among the following is incorrect statement? So this was a question asked in NEET 2020. Okay, Priyanka has answered it as D. What about others? Okay, Komal has also answered it as D. So when you're talking about the interstitial compounds, so you know interstitial compounds in the small spaces, okay, the small atoms like hydrogen, carbon, these are trapped. So this is a correct statement. Then when you're talking about transition metals and their compounds are known for their catalytic activity due to their ability to form multiple oxidation state and to form complexes. So this is also a correct statement. When you're talking about chromium and Fe plus 2, so chromium, which is having D4 configuration, is a stronger reducing agent than Fe plus 2 in water. So this is also a correct statement. So when we check the oxidation states of chromate and dichromate, okay, this is chromate, this is dichromate. So chromium plus 4 into minus 2 is equals to minus 2. So X minus 8 equals to minus 2. So x, okay, minus 2 and plus 8. So this will be plus 6. So this is the oxidation state of chromate and dichromate. So I'll write 2x plus 7 into minus 2 equals to minus 2 because there are two chromium ions. So I'll write 2x. So 2x minus 14 is equals to minus 2. 2x equals to minus 2 plus 14. Okay, so this becomes my plus 12. Okay, 2x, then x is equals to 12 by 2. So this becomes 6. So what is the last option? The oxidation states of chromium in chromate and dichromates are not same, but they are same. What we can see, it is x. So this is the incorrect statement. So option D is the right answer. Uh, so many have answered. So yes, Anvita, Komal, Priyanka. Yes. So D is the okay. So D is the right answer. Okay, D is the right answer. So we'll go for the next question. The calculated spin or the magnet movement of chromium ion is chromium plus 2 ion is okay. So A 3.87 bm, B 4.90 bm, and D C 5.92 bm, D 2.84 bm. So please calculate this magnetic moment of chromium plus 2 ion. Yes. So after calculating the magnetic moment, so you have to use this particular formula. So what is the formula? It is root of okay, mu is equals to root of n into n plus 2. Okay, so this is a formula for calculating the magnetic moment. So when you see the electronic configuration of chromium plus 2, okay, chromium is what? Chromium is argon 3d5 4s1. So chromium when it is plus 2, so it will be argon 3d4. Okay, so when you write the so the electrons are only 4. So 4 unpaired electrons are present. So mu is equals to 4. 4 plus 2. So after calculating, you get it as 4.90 bm. So option B is the right one. Okay. So now similarly, one more question is there. So but in this, how it is asked, just to see. Okay. So this is a question. Magnetic moment is given. So magnetic moment is given as 2.84. What is the magnetic moment given? Magnetic moment is given as 2.84 bm. Okay. And you have to tell which for which ion it is having this magnetic moment. Just go through, just calculate and tell me. Okay. Okay. Nagalambika has replied it as C. What about others? Okay, Jyoti is also saying it as nickel. You have to calculate. So when such question is given, what you have to do, you have to calculate the magnetic moment for all. Okay, all the options which are given, and then you can see which is the answer. So 2.84. So when you are calculating 2.84, okay, so magnetic moment, that is 2.84 bm. Okay, so this will be for what? So answer will be C. Yes, nickel plus 2. Yes, nickel plus 2. So when you are writing for chromium, chromium plus 2, the number of unpaired electrons will be 3d4. Okay, so you have to substitute in this formula, that is root of n plus 2. Okay, so this formula you have to put 4. Then when you are seeing for cobalt plus 2, cobalt, it will be 3d7. Okay, 3d7. So the unpaired electrons, when you are writing unpaired electrons, it will be how? 1, 2, 3, 4, 5. So it will be 1, 2, 3, 4, 5, 6, 7. So unpaired electrons are 3. So the unpaired electrons are 3 here. Okay. Then we are seeing for nickel plus 2. Nickel, when you are talking for nickel plus 2. So nickel plus 2, it will be 3d8. Okay. So when you are writing the 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. 6, 7, 8. So unpaired electrons will be here 2. So you have to substitute n is equals to 2. Then titanium plus 3. Titanium plus 3, the 3d1. So the unpaired electron is 1 itself. So after solving this, so for nickel, okay, nickel, you will get the Bohr magnetum value as 2.84. Yes, so many have answered it as C. So option C is the right answer. So we'll go for the next question. 15th question. Okay, here. Check the 14th question. Okay, 14th. Which of the following statements about the interstitial compounds is incorrect? A, they are much harder than the pure metal. B, they are having higher melting point than the pure metal. C, they retain metallic conductivity. D, they are chemically reactive. So which of the following statements about the interstitial compounds is incorrect? Yes. Okay, so option D, yes. So option D is the right answer. The statement, that is statement which is wrong is option D, because interstitial compounds are generally chemically inert. Okay, they are not reactive. They are generally chemically inert. Okay, so this is the incorrect statement. So we'll go for the next question. So 15th question, identify the alloy which is containing a non-metal as a constituent in it. So you have to identify the alloy which is containing a non-metal as a constituent in it. A, invar, B, steel, C, bell metal, and D, bronze. So this was a question asked in mains 2012. So B. Okay, Nagliambika has said it as B. So in Invar, okay, Invar is a alloy. In this, it consists of nickel metal plus Fe metal. Okay, it consists of what? It is consisting of nickel and Fe metal. Then in steel, it consists of carbon plus Fe metal. Okay, that is iron. Then in bell, that is bell metal, it consists of copper metal plus tin. plus iron metal. Okay, so these are the alloys. Then in bronze it consists of copper plus tin. So the option is B. So B is the correct answer, wherein you are having a non-metal. So you know carbon is a non-metal. So the alloy which is containing a non-metal constituent in steel is the carbon. So B is the answer. Okay. So B is the answer. So these are the compositions of the alloys. So Invar, it consists of nickel plus iron. Then steel, it consists of carbon plus iron. Then Bell consists of copper, tin and iron. Bronze consists of copper and tin. So we'll go for the next question. The catalytic activity of transition metals and their compounds is ascribed mainly to A, their magnetic behavior, B, their unfilled d orbitals, C, their ability to adopt a variable oxidation state, and D, their chemical reactivity. So this was a question asked in mains 2012. So what is the catalytic activity of transition metals and their compounds is mainly ascribed to what? So why the transition metals, they show catalytic activity? It is due to, yes, it is due to their ability to show variable oxidation state. So you know that transition metals, they have the ability of showing variable oxidation state. So because of the variable oxidation state, they will show the catalytic property or catalytic activity. Okay. So we'll go for the next question. So which of the following ions will exhibit color in aqueous solution? A, lanthanum 3 plus. Okay, that is lanthanum. Then B, titanium 3 plus. Then C, lutetium. And D, scandium. So which of the following ions will exhibit colors in aqueous solution? So which ions will show exhibit colors when they have unpaired electrons? So the ions, if they have unpaired electrons, then only they will show. So what you have to do, they have given the atomic number. So write the electronic configuration. Then you have to write the electronic configuration in the respective state. That is for titanium plus 3. Then you have to see how many electrons are present in d orbitals. If there are unpaired electrons present, then if any of this will show unpaired electrons, then they will be color. Okay, so like this. So just try solving this. Okay, Komal has answered it as B. Anvita has answered it as B. Priyanka B. Nagalambika B. Jyoti has also answered as B. Okay, so it is okay. So when you write the electronic configuration, so ions, as I said, ions which have unpaired electrons, they exhibit color in aqueous solution. So titanium. Okay, so when you write titanium, so electronic configuration in the outermost state, it will be what? Titanium plus 3. The electronic configuration will be 3D1 4s0. Okay. So 3D1 4s0. So the unpaired electrons are only one. So its solution will be colored. Okay. So other solution, that is lutetium, lanthanum, scandium. So these are colorless. Why? Because of empty or completely filled outermost electron. So in this, the electronic configuration is either completely filled or it is half filled. Okay. Or it is empty. So because of this, titanium. So the answer is titanium. So titanium, as the outermost electronic configuration, there is only one electron. So it will show this particular this. Okay. So we'll go for the next question. Which of the following pairs have the same size? Okay. So why they will show same size? Due to lanthanide contraction. So we have seen this earlier. So which is a pair which will show similar size? So this was a question asked is 2010. Nagalambika has answered it as C. Komal has answered it as C. So C is the right answer. So hafnium plus 4 and zirconium plus 4. Okay, so they belong to which group? They belong to 4b group. But hafnium, okay, plus 4, it has same size as zirconium plus 4. It is due to addition of 14 lanthanide elements before it, and in which the electrons are added into the F subshell. Okay, and these F subshells, the electrons which are present in F shell subshell are having poor shielding. Okay, poor shielding, and thus the on the outermost electron, and the contraction size will occur. So there will be contraction in the size also. So because of the F4F electrons, as they are having poor shielding effect, the 6s electrons will be pulled strongly. Okay, so thus the answer is what? The answer is C. So because of lanthanide contraction, they will have similar size. Remember this zirconium and hafnium. Okay. Next question. Which one of the elements with the following outermost electronic configuration may exhibit the largest number of oxidation state? So which of the elements with the following outer electronic configuration will exhibit larger number of oxidation state? Okay. So what is the theory behind it? Okay, greater the number of valence electrons, more will be the number of oxidation states. So if the, you have to see what? You have to see the electronic configuration. So the greater number of valence electrons, so if the number of valence electrons are more, okay, if the number of valent electrons are more, then the number of oxidation state exhibited by the element also will be more. So 3d5 4s1 can show maximum number of oxidation is plus 6. So 6 oxidation states it can show. Then 3d5 4s2, okay, it can show maximum 7 oxidation state. Then 3d2 4s2, it can show maximum 4 oxidation state. 3d3 4s2, it can show 5 oxidation states. So which can show maximum oxidation state is B. Okay, B is the correct answer. So the total number of valence electrons, okay, the total number of valence electrons, if it is more, so number greater the number of valence electrons, more will be the number of oxidation state which is exhibited by the element. So the maximum oxidation state shown will be by 3d5 4s2. Okay. Okay. Which one of the following characteristics of the transition metals is associated with their catalytic activity? A. High enthalpy of atomization. B. Paramagnetic behavior. C. Color of hydrated ions. And C. Variable oxidation state. So which of the following characteristics is associated with the catalytic property? Yes. Okay. Nagalambika has answered it as D. Ullas D. Yes, everybody has answered it as D. Yes. So the catalytic behavior of transition elements, it is due to what? It is due to variable oxidation state. Okay, it is due to variable oxidation state. Yes, Anvita, Jyoti, Komal, Ullas, Priyanka, Naglambika. Yes, the answer is right. Good. Okay, so variable oxidation state. Which of the following shows maximum number of oxidation state? Just now we have seen, right? It is C. Yes, it is C. It is manganese. Okay. What they have asked, there they had given it in electronic configuration form. Okay, they had given it in the electronic configuration from here directly they have asked. They have given the name of the elements. Here what you have to do, here you have to write the electronic configuration for each element, and then you have to tell which of the following will show the maximum. So just the way of asking is different. Okay, so way of asking is different. So it is a same question. Just the method of asking is different. So again here we have seen this bell metal is an alloy of bell metal. So just now we have seen this question, just the questions are repeated. Okay, so just I'm whichever are the important questions, okay, just I'm going through that. So metal is used of what? Just now we have seen this. Bell metal is an alloy of what? Yes, it is made up of copper and tin. Okay, it is made up of 80% copper, okay, and 20% tin. Okay, so B is the answer. Okay, B is the answer. So we'll go for the next question. Okay, so we'll see some of the important compounds of transition elements. We have discussed about the some of the important compounds, right? So this is a question based on that. So the manganese and permanganate ions are tetrahedral. Okay, so the manganese and permanganate ions, they are tetrahedral. It is due to what? The pi bonding involves overlap of d orbitals of oxygen with d orbitals of manganese. B, the pi bonding involves overlap of p orbitals of oxygen with d orbitals of manganese. C, there is no pi bonding. D, the pi bonding involves overlap of p orbitals of oxygen with p orbitals of manganese. Yes. Ulhas has answered it as D. What about others? So I'll write the structure. So Mn, manganese. Manganese will be O minus. Okay, this is the structure of manganese. O minus. So this is having tetrahedral. Okay, it is having tetrahedral structure. Then permanganate. Okay, permanganate ion, that is Mn. Bond bond O. Okay, O minus. This is also tetrahedral. Okay, this is also tetrahedral. It's fine. So in manganate and permanganate ions, the pi bonding takes place by overlap of p orbitals of oxygen. Okay, p orbitals of oxygen with d orbitals of manganese. So the overlap takes place between the p orbitals of oxygen and d orbitals of manganese. So option B is the right answer. So what is happening in permanganate? The pi bonding, it takes place by overlap of the p orbitals of oxygen. So from because oxygen, what is the electronic configuration? 1s2, 2s2, 2p. 2, right? So the electrons are 2p4, right? So the electrons are from p orbitals. So the overlapping, the pi bonding overlapping takes place from p orbitals of this and d orbitals of manganese. So manganese electronic configuration is 25. So it will be 3d5, 4s2. So from 3d orbitals, so the overlapping takes place between p orbitals of oxygen and d orbitals of uh, manganese. Understood? So this is the answer. Next question. When neutral or faintly alkaline KMnO4 is treated with potassium iodide, iodide ion is converted into X. What is that X? So this was a question asked in Odisha NEET 2019. Okay. So what is the question here? When KMnO4 is treated. Okay. So in neutral or faintly alkaline solution. So if MnO4, that is KMnO4, when it is treated with water, because it is alkaline or faintly, and it's treated with potassium iodide. Okay, it gives you what? It gives you MnO2 plus hydroxide ion plus IO3 minus. So option C. So this is a reaction iodate. Yes, it gives iodate, that is IO3 minus. Okay, so option C is the right answer. Yes, option C is the right answer. So when KMnO4 iodide, okay, iodide ion is converted into iodate. Okay, so IO3 minus. This is the correct answer. So we'll go for the next question. Which one of the following ions exhibit DD transitions and paramagnetism as well? So which of the following ions will exhibit DD transition and paramagnetism? So this was a question asked in NEET 2018. Rupi has answered it as C. Ullas has answered it as D. In chromate, okay, in chromate, that is CrO4 minus 2, chromium is in what state? It is +6 state. Okay. So there is no unpaired electron, so it is diamagnetic in nature. So this is diamagnetic in nature. Then dichromate Cr2O7 2 minus. Here also the chromium is in +6 state. Number of unpaired electrons is 0. This is also diamagnetic in nature. Okay, diamagnetic in nature. Then next is MnO4 minus. This MnO4 minus, Mn is in +7 state. The unpaired electrons here is also 0. So this is also diamagnetic in nature. Okay. Then the last is MnO4 minus 2. Okay. Here, Mn is in +6 state. The unpaired electron is 1. Okay. So it is paramagnetic in nature. So in MnO4 minus 2, one unpaired electron is present which in d orbitals, and therefore dd transition is possible. So if dd transition is possible because of the paramagnetic behavior. So if unpaired one also unpaired electron is there, then there will be dd transition possible. So this is MnO4 2 minus. So option D is the right answer. Okay, so we'll go for the next one. Name the gas that can readily decolorize acidified KMnO4 solution. A, SO2, B, NO2, C, P2O5, D, CO2. Komal has answered it as A. Jyoti has answered it as B. Naglambika, D, SO2. Okay, so the gas, okay, which is readily decolorizes this KMnO4 solution is A, that is SO2 gas. Yes, SO2 gas. So SO2 gas, what it does, it decolorizes the pink violet color of acidified KMnO4 solution. So if I want to write the reaction will be KMnO4 plus 5SO2. 2 KMnO4 plus 5SO2 plus 2H2O gives you K2SO4 plus 2MnSO4 plus H2SO4. Okay, so it turns this pink color to colorless. It turns what? It turns to pink color to colorless. So this is the reaction. So SO2 gas. So what you do, if you react SO2 gas with KMnO4 solution, it decolorizes the pink color to colorless. Okay, so this was a question asked in NEET 2012. Okay, this was a question asked in 2017. Okay, so we'll go for the next one. So last question, and then we can end this session. So which of the following statement is correct when SO2 gas is passed to acidified K2 Cr2O7 solution? A, SO2 gas is reduced. B, green Cr2SO4 thrice is formed. C, the solution turns blue. D, the solution is decolorized. So this was the question asked in 2016. Okay, the same question. Right, here what they have done, this is for K2Cr2O7, okay. K2, potassium dichromate. So that was the solution asked for KMNO4, that is potassium permanganate. So K2Cr2O7, when you treat it with H2SO4, acidified means you have to treat it with H2SO4 and you have to treat it with sulfur dioxide. It is turned into what? It is turned into K2SO4 plus Cr2SO4 thrice plus H2O. So it turns, that is orange color solution. This K2Cr2O7 will be orange color to green color. Okay, so option B, that is green Cr2SO4 thrice is formed. Okay, so yes, so it is B. Answer is B. Ulhas has answered it right. So B is the correct answer. I hope you have understood today's questions. Yes. So the remaining part, so we have completed about the questions from electronic configuration, then general properties of transition elements. Then we have started with some important components of transition elements. So few more questions we will see from here, and then we'll see the questions from lanthanide, actinides, and some applications of D and F block elements. Yes. So I hope today's session is clear. Okay, so we shall end the session here. So we'll meet in the next session. Okay. So thank you.